Oceanography observatories have been used for a long time. Out in any harbor, you have buoys. They sit out there in the ocean and they collect data on wave heights, currents, winds, temperature, and that information gets reported to shore. In a lot of ways, this is like that, but instead of the climate at the surface of the ocean, we're monitoring the climate deep below the seafloor.
We want to take a scoop sample of mussels.
Observatories are fundamentally different from going out in the field and grabbing a sample and coming home and then you do your work, for example. And so people have observatories set up in national parks. They have observatories set up near the North and South Pole. They have observatories set up on the moon. There are observatories set up in many places. And the concept is that you stay there for a while because most natural systems aren't the same all the time. They change. And if you can collect samples and collect data over time, you start to understand how the system works. That's what I would call a passive experiment. You place yourself in a location and you wait to see what happens. And a lot of very exciting science gets done that way. You simply don't know what you're going to find. If you hang out near a big river long enough, you'll see a flood. That's pretty exciting. But you don't necessarily know in advance exactly when a flood is going to occur. So you need to have an observatory simply to be there when something interesting happens. And in the case of our subsea floor observatories, this can be anything from an earthquake to a magmatic event where there's an eruption somewhere nearby, other changes that we simply can't anticipate. In addition, the observatories let us do experiments where we change the environment. We actually cause the change to occur. So for example, in these seafloor observatories, we're going to do an experiment this summer where we approach one of these using a remotely operated vehicle and attach a new instrument to the top of the observatory. It's called a flow meter. Now, in this area, the observatory has sealed off the seafloor, but there's a lot of water down there and it's vigorously circulating because it's hot. It's about 65 or 70 degrees Celsius. Now, that hot water is convecting and circulating through the crust, and it's a little bit overpressured relative to the ocean water above it. What we're going to do to this observatory is put a flow meter on top of it and open up a big valve and just let that hot water flow out. Now, that's going to do a couple of things. For the chemists and the microbiologists, they're very excited about sampling that water because by letting that water flow at a rapid rate, they're going to be able to collect really high quality samples that haven't been disturbed much by the sampling process. In addition, by venting that cork, we're going to be lowering the pressure in the ocean crust below. And that pressure drop is going to propagate out into the ocean crust. And we have other observatories as far away as 2.5 kilometers, which will see that pressure change. And the nature of that pressure change relative to the rate of flow out of the main observatory where we put on the flow meter, that tells us about the properties of the crust between the two sites. Now, this kind of experiment has been done a lot on land. It's been done in groundwater aquifers, it's been done in gas reservoirs and oil reservoirs, and it's a common approach that's taken to testing the properties of the rock, but it's never been done in the seafloor. And the reason it hasn't been done is because in order to do this test, you need multiple holes that you can monitor at the same time. Well, if you're working with a drill ship, you can't do that. You have one hole that you can monitor at once. So by having these observatories, these corks set up, they create a virtual presence. They let us monitor and collect data and samples at many holes at one time. And then we create a change. We know exactly what change we're creating. We know when it started. We know how big it is. And then we look over to another observatory and we watch the timing and the significance of the change there. It's a very controlled experiment using the seafloor as a natural laboratory. And that's just one example. There are many other kinds of these perturbation experiments that can be run once you've set up a series of observatories relatively close to each other like this.